So chi-square problems look scary. They look smart, right? You're going to look smart when you do it. They're not. You're just going to take it step by step. And as soon as you take it step by step, the nice thing is it's going to repeat every single time. Now, on the test, both mine and the AP test, you're going to be given that formula sheet. And that formula sheet has the chi-square table that you need to get the degrees of freedom. So there's no need to memorize that. And it also has the formula, right? Chi-squared is the sum of observed minus expected over expected. So you don't have to memorize any of that. You just have to know where it is and how to use it. Like any problem, we're going to read the problem first. So it says, a genetics engineer was attempting to cross a tiger and a cheetah. She predicted the phenotypic outcome of the traits she was observing to be in the following ratio. So 4 were stripes only, 3 were spots only, and 9 were both stripes and spots. When the cross was performed and she counted the individuals, she found that there was 50 with stripes, 41 with spots, and 85 with both. According to the chi-square test, did she get the predicted outcome? So with the chi-square, you are going to make a chart. Okay, that's the first thing you're going to do. And the chart goes R row, right? R-O-E. R is for ratio. O is for observed. E is for expected. Then you're going to put the traits on the side. So I'm going to do stripes, spots, and I'm going to put B for both. You can do, ST/SP, whatever you want to do, or however you want to do that, but I'm just going to put both there. Now, for this particular problem, it actually gives you the ratio, the expected ratio, right? She was expecting or predicted that it would be 4 to 3 to 9. Now, because she gives you that, right, you're just going to write down 4 to 3 to 9 as your ratio. If they don't mention a ratio, that's where you're going to use those standard Mendelian ratio numbers that I had you memorize. The 9 to 3 to 3 to 1, the 1 to 2 to 1. You just assume those ratios. So unless it gives you a ratio in the problem, you assume Mendelian ratios. So that 9 to 3 to 3 to 1, 1 to 2 to 1, 3 to 1. This one, though, it gives you it, so I'm just going to write them down. Then it tells me what she observed. So she had 50 with stripes only, 41 with spots only, and 85 with both. So the ratio is either going to come from the problem or just, the number that you memorized. The observed will always, always, always come from the problem. The observed will always come from the problem. The E expected will always be calculated by you. So observed, always from the problem. E is what you're going to calculate. And here's how you calculate it. First thing you need to do is you need to total up the R and the O. So I'm going to get 16 for the R and 176 for the O. And what you're going to figure out is if this is my expected ratio. So for example, my expected ratio for stripes is that 4 out of 16 will be striped every single time, because that's my expected ratio, 4 out of 16. So what I'm going to say is, if the ratio is 4 out of 16 and I counted 176 total individuals, how many would I expect if it followed the ratio perfectly? How many should have stripes? So I'm going to do 4 out of 16 times the total. And in that case, it's going to give me 44. So you're always going to do the ratio times the total to get the expected. So you're going to do 4 out of 16 times 176 to get 44. So what this is saying is, if there's 176 total and it followed this 4 out of 16 ratio, 44 should have had stripes. So I'm going to do that for each one. So my spot ratio is 3 of 16. So I'm going to do 316 times 176, and you would get 33. And then for the last one, I'm going to do 9 of 16 times 176, and I'm going to get 85. Oh, I'm sorry, 99. So again, to get the expected, the O, always in the problem, the E, you're calculating it. To get the E, you're going to do the ratio So 4 out of 16, 3 out of 16, 9 out of 16 times the total. You never multiply by the observed number, just the total. So this is telling me this is what I got, this is what I should have got. This is what I got, this is what I should have got. And you're going to say, basically with your chi-square, is that close? Is that close enough that you can say, yes, the ratio was observed? So your formula for that is right here. Remember, x squared is the actual, that's the, like saying A, B, C, D, right? You don't square it or anything or take the square root. And you're always going to do observed minus expected squared over expected. Now I'm going to write this out just, to help you guys see it. You don't necessarily have to write it all out every single time. So again, the first one is going to be O, so that's 50, minus expected, 44, squared over expected, 44. And I'm going to do that for each trait. So I'm going to do the O, 41, minus expected, 33, squared, over the expected, 33. And notice I'm adding them because it's going to be sum of. So 85 minus 99 squared over 99. So that's kind of this all written out here. And it's sum of, so I add them all. Now, if I did those individually, again, the amount of work you show here is kind of up to you. So this is going to be equal to 0.82. I am always rounding to 2 decimal places. 1.94 and 1.98 to get a final chi-square value for this of 4.74. Okay. So that is my chi-square value. I am not done, but that is my chi-square value. In order to answer the question, did she get the predicted outcome? Was the observed numbers close enough with some expected, it being a little bit off to say that the ratio held true? So the way that I figure that out is I figure out first my DF, my degrees of freedom. Degrees of freedom is the number of traits minus 1. So if I look here, basically you're counting how many you had here. So there's 1, 2, 3. If I had 4, it'd be 4. So I'm going to do 3 minus 1 is going to give me 2. And then here's the big one. That 2 tells me, so I go up here and I say, okay, here's degrees of freedom, 1, 2, 3, 4. Remember, there's 0.05 and 0.01. We're always going to do 0.05. If you want to, I told you can just cross out 0.01 right on your thing. We're never doing that. So I'm going to go to degrees of freedom, 0.05 is 5.99 right here. I'm getting that right from the chart. So you can say, underneath here, this is 5.99. And then what you do is you compare the answer that you calculated right here to this accepted value. So I'm just going to write it out. I'm going to say 4.74 is less than the 5.99. So what you're doing here is you're saying, here's what I got. Here's how off my numbers were. And then according to this chart, how off were they allowed to be? So they were allowed to be at maximum 5.99 off. Mine were only 4.74, less than. So if it was less than the maximum allowed off, you would say that it was accepted. So you just put accept there. Now, if this answer got to be like this was 10 or 9, 9 is greater than 5.99, that means it's too far off. It's too outside of those ratios, and you'd say it was refuted.